Hi. So today we start our topic that is about the dienes of the organic chemistry. Great bachelors. In the start, we introduce our topic that is about the dienes, right? So dienes are the unsaturated hydrocarbons with a carbon-carbon double bond in the molecule. These are represented by a general formula that is CnH2n minus 2, which means that they are isomeric with the alkynes. Alkynes are the other class of the organic compound, just like alkenes and the alkanes. However, their properties are quite different from those of alkynes, just their formulas are similar. So, simply, dienes are the compound, they are the unsaturated hydrocarbons having multiple double bonds between the carbon carbon, like these are the dienes. This means that they have two double bond between the carbon carbon chain. For example, we have a compound that is a four carbon compound, we call it a butane. So in a butane, for example, if we have a two double bonds are present at different position, this means this is the structure of the diene. Di word means two, and ene means definitely alkene. This means that two double bonds are present in a compound, so we call it a diene, right? Now we have an example that this is the example having a five carbon compound and two double bonds are present in different positions. So we named this compound as the penta 1,4 diene. Why? Because at the carbon number 1 and the carbon number 4, the double bond are present. So we call it a penta 1,4 diene. Actually, we have, after the basic introduction, we are moving towards the types of the dienes. So initially we have three types of the dienes. The first one is the isolated diene. The first one is the isolated diene. The second one is the conjugated diene. And the third type is the and the third type is the cumulated diene. Right? These are the three types of the diene. So now we are studying about the first, that is the isolated diene. So isolated diene is also called as the non-conjugated diene. In an isolated diene, the two double bonds are separated by more than one double bond. Actually, in all the three types, the only two double bonds are present because these are the types of the dienes, right? This means that they all contains only two double bonds in their structure, but the position of the double bond is changed in all the types. So according to the position of the double bond, we categorize them into into three types or three classes. The first one is the isolated diene. Isolated diene is also called as a non-conjugated diene, right? And it contains two double bond which are separated by more than one single bond. This means that for example, we have a five carbon compound, carbon number one, two, three, four, and five. And these are the five carbon compounds. And they said that between the two double bonds, there are multiple single bonds, right? For example, a double bond is present at the position number one or the carbon number one. So for the between the next double bond, there is a gap of multiple single bonds are present. Or we say that like the next double bond is present at the carbon number four, right? This is the carbon number two, carbon number three, carbon number four, and the carbon number five. So another double bond is present at the carbon number four. So we said that in an isolated dienes, the two double bonds, right? The first double bond and the second double bond, the like between the two double bonds, or we say that the two double bonds are separated by more than one single bonds. These are the two single bonds, right? So the two double bonds are separated by more than one single bond, right? So this is called as the isolated diene. So this is the example of the isolated diene, which is the penta 1,4 diene, and the second one is also the example of the isolated diene. So this is also a five carbon compound, one, two, three, four, five. But on the carbon, there's a difference that on the carbon number three, there is a methyl group, right? There is a methyl group. So we called them the three methyl penta 1,4-diene. 3-methyl, like on the carbon number 3, a methyl group is present. So on that is 3-methyl, 3-methyl penta, because it is a 5-carbon compound. And on the position number 1, the position number 4, a double bond is present. So it becomes 3-methyl penta 1,4-diene, right? Now we are moving towards the next class of the diene, that is the conjugated diene. Okay, so in a conjugated diene, the two double bonds are present in a conjugated or alternate positions and are separated by a single bond, right? This means that the double bond or a single bond are present on the alternate positions. For example, we have an example that is the buta 1,3-diene, in which we see that like double bonds are present on the alternate position. The first bond is the double bond, then we have a single, then again double. Or if this class of the carbon compound is continuing, so we see the same scheme that this double or single bonds are present on their alternate positions, right? So it becomes buta because it is a 4-carbon compound, and the double bond is present at the carbon number 1 and then the carbon number 3. So it is buta hyphen 1,3-diene, right? We have another example that is, for example, we have CH2 double bond CH, then we have a single bond CH2, then we again have a double bond CH, and then we have CH2, right? Yeah, CH3. And if we say that on the carbon number, yeah, this is here C2H6, an ethyl group is present, right? 1, 2, 3, 4. Hydrogen is not present at this position. Okay, now this is yeah, this is a class of carbon compound. So what is actually, this is again a conjugated diene because the double and single bonds are present on their alternate positions, or between the two double bonds there is only one single bond, like double bond, single bond, double bond, and then single bond. So if we write the name of this compound, so this is actually a 1, 2, 3, 4, 5. It's a 5-carbon compound. This means it's a pent, right? And an ethyl group is present at the carbon number 3, so we call it a 3-ethyl penta 1, 1, 2, 3, 1 and 3, yeah, 1, 3 diene, right? Now this is the class of a conjugated diene, right? Because the double bonds are present on the alternate positions. The last class of the organic of the diene is the cumulated diene. Actually, cumulated diene, in this case, the two double bonds in the molecule are present at the adjacent positions, right? Here, the double bond is present at the adjacent positions. So, for example, we have an example that is there. It is a it is a class of a compound having 3 carbons. So we called it a propene, right? And now we see that the double bonds are present on the alternate position. Here, double bond is present, and also at this position, the double bond is also present. So it is now the double bonds are present at the adjacent positions. So the name of this class of the compound is like it is propane, right? Propane, right? One, and you said two. 1, 2 diene, right? 1, 2 diene. And also this is another example. So it is a 4-carbon compound. So we call it a butane. Like it is at the carbon number 1, the carbon number 2, the double bond is present. So we call it the but 1, 2 diene, right? So this is another example of the cumulated diene. So we have actually 3 classes of the dienes, or we say that we have actually 4 types of the diene. The first one is the isolated diene. The second one is the conjugated diene, and the third one is the cumulated diene. Now, there is another question that keeps in the student's mind, and that even came in the exams, that like out of these 3 types, which one is the most stable type, or which one is the most stable class of the diene? Either it is isolated diene, either it is a conjugated diene, or a cumulated diene. Or if like anyone, we say that, for example, a conjugated diene is the most stable one from both, then why it is more stable? So the next slide is all about the stability of the dienes, of any class of the diene. Okay, now we compare the relative stability of the isolated diene, right? Now we compare the relative stabilities of the conjugated and the isolated diene. In the first slide, we are comparing the stability of these two, like the isolated one, and the second one is the conjugated diene. And after that, we are moving towards the stability of the three types conjectively, right? So the first one is the isolated diene, and the second one is the conjugated diene. Okay, wait. First of all, I'm removing the. Uh, okay. Now we are moving towards the main slide. So it is all about the comparison of the relative stabilities of the isolated and the conjugated dienes, right? So there is a resonance theory. First of all, we compare the two examples of the isolated as well as the conjugated diene. First, we have an example of the conjugated diene. For example, there is a compound that is CH2 double bond CH. Then we have a single bond CH. Then we have a double bond. And after that, we have a single bond, right? So this means that yeah, it is a five carbon compound, and the double bonds are present on on their alternate position, like double, single, double, single. This means that it is an example of the conjugated diene, right? So, for example, if the double bond, like I'm showing the resonance effect of this compound, right? So, if the double bond is present between the carbon number one and the carbon number two, and I say that now I shifted this double bond on the carbon number one, right? So it make a structure that is the it make a structure that is the like CH2. Now the double bond is shifted on the carbon number one. So a negative charge is created on this carbon, right? And now a single bond is present here, and also a positive charge is present on the carbon number two, because it like loses its lone pair, not a lone pair, it loses it's a bond, right? So because of this, a positive charge is created on the carbon number two, and then we have a CH, and after that we have CH and CH2, right? So this is the another structure of this compound, right? Okay, after that there is another possibility. For example, there is another possibility that like if I I say that if I shared this double bond to this carbon, like for because a positive charge is created on the carbon number two, and if I share the double bond which is present on the carbon number three, and then I shared it to the or donated to the carbon number two, so another structure is possible, and that structure is like we have a CH2, and we have a negative charge in this carbon, right? And then we have a CH, right? When I shifted this double bond to from the carbon number three to the carbon number two, so this positivity is now removed, and a double bond is formed. So the valency of the carbon is now completed, because there are two double bonds, and a single bond, three bonds, and a bond which formed by the hydrogen. So now the four valency of the carbon is now completed. So the positive charge is removed here. After that, we have like a single bond at this position. So because of this, a positivity is created on the carbon number four, because when it loses its bond, so a positive charge is created on this carbon, right? And after that, we have a CH2, right? So these are the three possible structures of this compound, and the name of this compound is that is a five carbon compound, one, two, three, four, five. This is a pent, or we say pent, then one, two, three. On the carbon number one, on the carbon number three, double bond is present. So it is pent one, three diene, right? It's pent one, three diene. So these are the three possible structures, or we say that there are three possible resonating structures of this penta 1,3 diene, resonating structures of this penta 1,4 diene, right? Okay. After that, we have this is the example of a class of a compound of a class of a conjugated of a diene, that is the conjugated diene, right? This is the example of a conjugated diene. Actually, I'm clarifying to the concept of the stability, relative stability of the three between the three classes of the diene. So this is the example from the conjugated diene. And the second one is about the isolated diene, right? The second one is about the isolated diene. Okay. After that, we have another example that is all about the isolated diene. This means that we know that in isolated diene, the double bonds are present, like between the two double bonds, there are more than one single bond. So, for example, it's also a five carbon compound, one, two, three, four, and five, and a double bond is present between the carbon number one and the carbon number two, and then we have a double bond on the last carbon, right? So, in this structure, here it is like CH2, it is like CH, CH2, CH, and then in the last we have CH2, right? So now we see that if I shifted this double bond to the carbon number one, right? This is the carbon number one, carbon number two, carbon number three, carbon number four, and the carbon number five, right? So if I shifted this double bond on the carbon number one, so uh, we say that another kind of structure is formed, that is CH2, then we have single bond, right? And then CH. And a negative charge is created on the carbon number one, and a positive charge is created on the carbon number two. And after that, we have a CH2, then CH, and double bond CH, two, right? So now we see that is there any other structure possible of this isolated diene? If I see that if I shifted this double bond on the carbon number like on the carbon number two, no, I cannot shift it because here the carbon number three, which is a CH2, is not involved in the resonance, right? Because if I shift this double bond on this position, so it already contains two bonds with the it also it already formed two bonds with the hydrogen and two bonds with the other carbon. So like its valency is completed, so it is not involved in the resonance. So just two structures of the isolated dienes are possible, and the name of the structure is like it is also a pentane, so it is pentane one. And now one, two, three, four, one, four diene, right? So this means that the possible resonating structures of the pent 1,4 diene, or we say that the possible resonating structure of the isolated diene are just the two resonating structures, right? The two resonating structure. This means that the conjugated dienes shows the three resonating structures, while the isolated dienes show the just the two resonating structures. Now we read this theory that the relative stability of the two types of the dienes can also be justified on the basis of the theory of the resonance. Pent 1,3 diene, which is an example of the conjugated diene, is a hybrid of the following structures. These are the structure which we already formed. So they said that the delocalization of a pi electron charge, because we know that like this pi electron charge is now delocalized on different positions. So they said that the delocalization of the pi electron charge because of the resonance decreases the energy. This is a very important point. It decreases the energy of the molecule or increases the stability, right? And the second one is the pent 1,4 diene has only two contributing structure, which is the example of the isolated diene, right? So this is a structure we also formed. So they said that in the example of the isolated diene, since the carbon number three is not involved in the resonance, like this is the carbon number three, it is not involved in the resonance. The contributing structures are less number are compared to the isolated diene. So the isolated diene is therefore less stable than a conjugated diene. We know that the stability is directly proportional or directly related with the resonating structure. If any compound have more resonating structure, this means that it is more stable than the other one. So according to this, like according to this specific or one reason about that is the resonance theory. So according to the resonance theory, we say that the conjugated dienes are more stable than the isolated dienes. I write here that the conjugated dienes are more stable. Dienes are more stable than the isolated dienes, right? Than the isolated dienes, right? There are dienes. They are more stable than the isolated dienes. So Now we are moving towards the next slide. That is about the conjugated dienes are more stable and the isolated dienes due to the following reason. The first reason we already studied in the last slide, that is the resonance stabilization of the resonance theory. Now the second point is about the second reason is the molecular orbital overlapping, right? So they said that the p orbital in a conjugated system overlap. Like this is the conjugated system. This is the conjugated double bond. So here the p orbital in the conjugated system overlaps, forming a delocalized pi system that extends over the entire conjugated chain. Right? And this delocalization reduces the electronic repulsion and contributes and distributes the electronic density more evenly, leading to the increasing stability. This is the second reason. And the last reason, or we say that not the last reason, actually it is the third reason, that is the hybridization effect, right? So this is a very important point. They said that the sp2 hybridized carbon in the conjugated diene. We know that all the carbons in the conjugated diene, right? All the carbon in the conjugated diene, they all are sp2 hybridized. While if we draw a compound from the category of the isolated diene, so we know that there is a carbon that is sp3 here, right? This is the carbon. The carbon number 3 is the sp3 carbon, right? Because it contains it contains all the sigma bond and no pi bond is formed. So it is its sp3 hybridized carbon. We know that three p orbitals and then one s orbital is formed like in this category. So we know that the sp3 sp2 hybridized carbon in the conjugated diene having a high s character, that is 33%, making their bonds stronger as well as shorter, right? And in contrast of the isolated dienes have a mix of sp2 and sp3 hybridized carbon, which leads to the formation of, or which leads to the weaker carbon-carbon double bond and the less stability, right? So this is another reason that strengthen the point that the conjugated dienes are more stable than the isolated dienes, right? Then we have a stability order of the all the three classes of the dienes. The first one, the conjugated, the isolated, as well as the cumulated diene. So they said that the conjugated diene are more stable than the isolated diene, and it is more stable than the cumulated diene. Now, we understand the first 2 points, that why the conjugated diene is more stable than the isolated diene. But now we studied the third class, the cumulated diene, why it is like unstable, or we say that very less stable than than both the classes. So the reason is the cumulated diene is a highly reactive due to increasing electronic density. Secondly, they lacks the the resonance stabilization, because we know that like in case of the cumulated dienes, the double bonds are present in their uh, on the adjacent positions, right? So here the resonance effect is not perfect. We know that like it lacks the resonance stabilization. And the third one is all the carbons of the cumulative dienes are the sp hybridized central carbon. So which disrupts the we know that which disrupts the pi orbital overlap, making the system less stable. So these are the 3 points which strengthen the point of the cumulative diene, that why it is unstable than the conjugated as well as the isolated diene. Right? Now we are moving towards the next slide, that is all about the properties of the conjugated diene, right? So the properties of the isolated dienes are similar to those of the simple alkene, but those of the conjugated dienes are somewhat modified because of the delocalization of the pi electron charge. And however, they also participate in the addition reactions, right? So the important chemical characteristic of the conjugated dienes are briefly discussed. So today we discussed the stability as well as the types of the classes of the dienes, and also we introduced from the with the basic concept of the dienes. So after that, in the next lecture, so we again cover we start from the point that what are the properties of the conjugated dienes, and we discussed this conjugated diene in detail, like what are their properties and what are the reactions which are followed by the conjugated diene, right? So thank you so much. Until the next lecture, inshallah we will meet again in the next lecture. Until Allah Hafiz.